Yeah. So as I was telling you, that like serverless means it is not that there is no server on that, but serverless is still there is a server and everything is managed by cloud provider. So we will have an abstraction layer on top of cloud infrastructure. So where the user or the vendor who is using the cloud, so they will be using this abstraction layer, and underneath there is an infrastructure platform which is not at all, which is completely not at all visible to us. We just actually uh, use their environment for configurations and deployments. But underlying, there is actually server. So that's why it is an abstraction layer on top of cloud infrastructure. So then another main advantage is actually developers can focus on solving critical business problems, and they can bring quicker to markets, because that the project team where they spend almost 30 to 40% of effort in setting up the infrastructure, setting up the scaling things, next setting up the security related everything. That time will get saved actually with the serverless, so that everything will be ready on the cloud. Then we just develop the code, test it, and deploy it. So that's why we can bring that to quicker to markets. And that's what actually this all again depends upon, will affect directly proportional to the agility, reduce time to market, minimal overhead of infrastructure, and all that. And even nowadays we are seeing the digitization and digital transformation. So many people or many projects actually, they are going from legacies to modernization. So for the modernization of digital transformation, the serverless computing is very useful because of these features. And basically serverless compute, for example, if you take, it can be considered as one single entity, that is a granular computing resource, so that can process a particular business functionality. So especially in the digital transformation, when we do modernization, so many of the legacy services or the monolithic based services, they can be converted to microservices. And a microservice can be mapped to one serverless computing unit, so that where we can map a code to one deployment, so that can be run as one granular unit. And the main important thing, which I was telling in the earlier slide, like we have managed services and serverless. Managed services like PaaS, platform as service in the cloud, and serverless also. So many people will ask, actually, already we have PaaS, what serverless brings advantage? Because PaaS also, cloud provider will take care of the runtime, infrastructure, scaling, and everything. Then why serverless? So that this is where the difference that comes between PaaS or managed service and serverless. So the difference is, so managed service, though you are using the you are using the system or not using system, it will charge actually. But serverless, it is not like that. So it will not charge for idle times. It is like serverless, when you use only, it will be active. When you don't use, it will be in sleep. It is as if you are putting your system in hibernate mode. Actually. So as you are working in laptop or something, you will be putting in your hibernate mode. That is an idle. Again, actually, when again any request or any processing request comes, or any request comes from external thing, so then it will again start. So there are some limitations to that, which we are going to see that also, like where we see some cold starts or something like that, because of that causes latency and all that. Yeah. But that is the main difference between the managed PaaS service and the serverless service. Where, for example, I'll tell you one simple scenario. When we go to Azure, Microsoft Azure, so there is a provisioned SQL and there is serverless SQL. So in provisioned SQL, what will happen is it is actually managed service. It's a complete platform service. There also, you don't need to worry about infrastructure or OS or anything, security or patch, anything. But there the charge is per hour. I mean, both for serverless and this one, charge will be stored for storage area. But for compute, how it is charged is, compute only when the queries are getting executed, only for the particular execution time. In serverless, it is charged. But in PaaS, it is not like that. Suppose it will charge for hourly bill. For example, even if you use for 15 minutes, so it will charge for that particular hour actually. So that means for 15 minutes also, if you use, it will charge for 60 minutes. So, but serverless is not like, if you use only for 15 minutes, it will charge only for 15 minutes. So that is the main difference with serverless and this PaaS that you are bringing. So that's what actually will not charge for idle time. Yeah. It is as if actually it is going, your system is under sleep if there is no active action that is being undergone.
Yeah, I think even like for anyone who is already using managed services or in containers and stuff, right? So dedicated instances, I think is the right time to check it out, or what is the right way to check, right? So for I believe like under the CloudWatch monitoring, one can check how much idle resources are, right? And accordingly, they can take the decision. Okay, if we move to serverless,
Yeah.
and let's say 80% of resources are idle all the time, then I think they can save a lot of cost, right? Mm.
Yes. Yes. Yes, Praveen. That is correct. Yeah. So yeah, these are the building blocks like in serverless, mainly the cloud service provider responsibility for compute storage, security scaling. And with that, we can leverage event-driven computation that can even bring reduced time to market. And once it is quickly brought to the market, so product innovation group can start working on that with a lot of research capabilities. So
Yeah.
serverless brings product innovation very quickly and brings new things to the market very quickly.
Right. And when it comes to cloud provider, right, so it's a shared responsibility model for the HIPAA compliance, right? So
Correct. Yeah.
it has to be like, of course, they do side business associate agreements, but again, there are some aspects that engineering team has to take care when it comes to compliance.
Correct. Correct.
For example, masking in the logging, right? So we
Yeah.
can't log the PHI data, right? So one has to mask.